Welcome, Honors Algebra 2. We are starting with 1-3 today. So 1-3. And 1-3 is quadratic equations in the complex number system. Yeah. Quadratic equations in the complex number system. Okay, so what this unit is, up until this point, anytime we were solving quadratics and there was a negative inside the square root, we would stop and say no real solutions. And that is still true. There are no real solutions, but now what we're going to be incorporating is the complex number system. So let's talk about what the complex number system is. So the complex number system so it's the number system that includes the imaginary number I. A number system that includes the imaginary number system, or the number. I don't know why I need that S there. I whited it out. So includes the imaginary number I. So what is I? So just like how pi represents 3.14, yada, 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 yada. E represents 2.72 something, 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 something. I represents a number. So what I represents, I is equal to the square root of -1. So now we are including values when there is a negative inside the square root. So we're going to talk about simplifying i's. Now there is a pattern, and we'll kind of talk about that pattern. So I to the first, like I said, is the square root of -1. Now we typically will never write it as the square root of -1. Typically you take the square root of -1 and write it as I. Okay, so then we're going to think about what's I squared. And I'm going to get a side piece of paper for this because I'm going to have you guys think about it. So I squared is I times I, right? And we know I is the square root of -1 times the square root of -1. Well, the square root of -1 times the square root of -1, anytime you multiply the square root of a number by the square root of the same number, the square root goes away and you're left with just -1. So I squared is equal to -1. Okay, I cubed. Let's think about I cubed. So I cubed is I times I times I. Well, we know I squared is -1, and -1 times I is just going to be -I. And then I to the fourth. So I to the fourth would be I times I times I times I. Well, kind of going off of how we did it before, we know I times I is -1, and then we have another I times I, which is -1, and then -1 times -1 is +1. So I to the fourth is 1. Now, on the separate piece of paper, I'm going to keep going with I to the fifth and then a few others, but I'm not going to write it on my notes page right now. I'm just going to show you on this for right now. So I to the fifth would be I times I times I times I times I. Okay, well, we know I to the fourth, which is this, is 1. And so I to the 5th becomes 1 times I, which is I. So I'm just going to write this. So we have, where do I want to write this? Great question, Mr. Imperio. Okay, I'm going to write it here. So I to the 1st is I squared is negative 1. I cubed is negative I, and I to the 4th is 1. And then I to the 5th is I. I to the 6th, so that would be I times I times I, 6 times. Well, we know 4 of those i's come out to be 1. And then we know I times I, which is I squared, is negative 1. So 1 times negative 1 is negative 1. Okay, then I to the 7th, that's going to be I 7 times. 4, 5, 6, 7. They're starting to look like backwards J's, but they're I's. So we know I to the 4th, 4 of those is 1. And then we know I to the 3rd. Well, I to the 3rd, we got to be negative I. So 1 times negative I is negative I. So I to the 7th is negative I. Now, just looking at my pattern here, what do you guys think I to the 8th is going to be equal to? Well, if you're thinking 1, you would be correct, because it's really I to the 4th times I to the 4th, which is 1 times 1, which is still 1. I can keep going and going and going. I to the 9th is going to be I. I to the 10th is going to be negative 1. I to the 11th is going to be negative I, and I to the 12th is going to be 1. So notice every multiple of 4 is always going to be equal to 1. So as long as you have these 4 memorized, that's really going to help you in simplifying any of the other ones. And let's do some examples. So like I said, as long as you have these 4 memorized, you should be good to go with any other ones. So let's do some examples. Okay, so for these examples, I'm just asking you to simplify. So if I gave you, what's I to the 103? So there's 2 ways of thinking about this. I'll tell you like kind of how I think about it. There's actually a lot of ways. There's, I'll show you kind of how I think about it. I said that, but I'm saying it again. So one way that I think about it is I actually will take the 103, and I know that every multiple of 4 is always going to simplify to be 1. So I want to see how many times does 4 go into 103. So that's what I'm going to do. I'm going to divide 4 into 103. Well, 4 goes into 10 2 times. 2 times 4 is 8. Subtract 23. 4 goes into 23 5 times. 5 times 4 is 20. Subtract, and I have a remainder of 3. Now, what information does that give me? What information that gives is it's saying this is the same as me writing I to the 4th 25 times I to the 3rd. Because 4 times 25 is 100, and then 100 plus 3 is 103. So, again, to reiterate, notice how this number is what went here, and then the remainder, 3, is what went here. And anything that's to the 4th, I to the 4th, we know is going to be 1. So that's 1 raised to the 25th power times I cubed. Well, 1 to the 25th power, 1 times 1 times 1, 25 times is just 1. And I to the cube, or I to the 3rd power, is negative I. 1 times negative I is negative I. Now, that's kind of a longer way of thinking about it. I don't really deal with this as much. I don't deal with this I to the 4th to the 25th power and 1 to the 25th. all I look at is really my remainder. So if my remainder was 2, it would be negative 1. If my remainder was 1, it would be I. If my remainder is 0, it would be 1. My remainder was 4, I didn't do division right. So you're always looking at your remainder basically to get your final answer. Another way of doing it is using a calculator. You can use a calculator to help you also. And so one thing that I do is, so I would do 103 divided by 4, and then I look at that 0.75. Well, 0.75 is 3/4. Again, I to the third, negative 1. If it was 0.50, that would be 2/4, and that would be I squared. It would be negative 1. If it was 0.25, that would be 1/4. That would be I to the first, which would be I. And then if it was no decimal, then it would be 1. So we're always really looking at the remainder. The remainder is what's important here. So let's make a note of that. I'm just going to get my pen out. Okay, so when the remainder equals 3, the simplified answer will be I cubed or which I cubed equals negative I. If the remainder is 1, then that's going to be I to the first power, which is I. If the remainder is 2, it's going to be I squared, which is negative 1. And if the remainder is 0, it's going to be I to the fourth, or just 1. And if your remainder is 4, like I said, you've done division wrong. So keep going. You should have 0 then. Okay, so let's try one. So if I gave you I to the 38th power, I want you guys to think about that one on your own. So think about what method you prefer. Do you prefer dividing? Do you prefer using your calculator? And go with that. So pause me here, try it on your own, think about this one on your own, and then come back and see if you got the right answer. Okay, so I'll tell you one other way of doing it. I don't really do it with a bigger number like 103, but with 38, it's a little bit smaller. So I think about what's the closest multiple of 4 that's less than 38. And the closest multiple of 4 that's less than 38 is 36. And I know every multiple of 4 is going to be equal to 1. Now, what's left to get me 38 is I squared. So let's make note of that. Any multiple of 4 will always equal 1. So we know I to the 36 is a multiple of 4, so that equals 1. And then we know I squared is negative 1. And so 1 times negative 1 is negative 1. Okay, why don't you guys try thinking about this one on your own. So number 3, I to the 97th power. So pause me here, try and think about that one on your own, and then come back and check your work. So I to the 97th power, again, I think the easiest way is just using your calculator, but if you use any of these methods, great. But if you did 97 divided by 4, and I got 0.25, which is 1/4, it's going to simplify to be I. And that's it. Okay, so let's look at some square roots with a negative inside the square root. So let's go to 4. So if I took the square root of negative 25, now the square root of negative 25, we know the square root, we can break this up. So we know that negative 1 times the square root of 25, that's the same thing, right? It's just broken up into 2 radicals. Well, I know the square root of negative 1 is I, and I know the square root of 25 is plus or minus 5. So together, the square root of negative 25 is plus or minus 5i. And that's it. Okay, let's try another one. So what about 5? What if I gave you the square root of negative 50? Not a perfect square root, but what we can do, again, I would think about it as, okay, I'm having a hard time writing. The square root of negative 1 times the square root of 50. Now, the square root of negative 1, anytime you have a negative inside the square root, you can always pull out an I. So that can always come out. And then we could just think about 50. What's a perfect square that goes into 50? Well, we know it's 25 times 2. I know the square root of 25 is 5. And then the 2 can stay inside. So what this becomes is plus or minus 5i rad 2. Plus or minus 5 from the 25, I from the square root of negative 1, and then 2 because we can't take the square root of 2. So anytime you have a negative square root, you can always bring out an I from the square root. Okay, let's move on to a new section, which is going to be complex numbers written in standard form. Lots of awkward silence there, sorry. Should have paused it and just wrote it really quickly. So when you have a complex number, to write something in standard form, you always write the real part first and then the imaginary part. So if it's like an expression with addition and subtraction in between, you always write the real part first and then the imaginary part. So I'll show you an example what I mean. So let's do 6. So if I gave you negative times negative 5 plus 2i plus 2 minus I. So it's just really straightforward, just combining like terms. First thing I would do is distribute my negative to both the negative 5 and the 2i. And that gets me 5 minus 2i. I don't really need the parentheses around there because I'm just distributing a positive 1. So it's plus 2 minus I. And then I can just combine like terms. 5 plus 2 is 7. And then negative 2i minus I is negative 3i. And this is written in standard form because the real part comes first and then the imaginary part comes second. So 7 minus 3i is my final answer, and that is a simplified answer there. Okay, let's try multiplying. So with multiplying, if I gave you 3 minus 2i times 5 minus 4i. Okay, so multiplying with complex numbers is the same as multiplying if it was x instead. So we're just going to distribute. So 3 times 5 is 15. 3 times negative 4i is negative 12i. And then negative 2i times 5 is negative 10i. And then negative 2i times negative 4i. Well, negative 2 times negative 4 is positive 8. And I times I is I squared. Okay, let's simplify from there. First thing, I squared. What do we know that I squared is equal to? Well, we know I squared is equal to -1. So instead of writing I squared, I'm going to write -1. And really what it's doing is saying 8 times -1, which means that this is 15 minus 12i minus 10i, and 8 times -1 is -8. And so now I can combine like terms. So whenever you have, like basically your answer should only have an I in it with no exponent. So I squared, you can simplify. I cubed, you can simplify. I to the 4th, you can simplify. Anything after that, you can simplify. So it should always be in terms of I with no exponent, or an exponent of 1 technically. And then I can just combine my like terms. So 15 minus 8 gets me 7. And then -12i minus 10i gets me -22i. Again, that is in standard form. I have the real part first and then the imaginary part second. Okay, so let's try one more in multiplying. So if I gave you 7 plus 5i times 7 minus 5i, I want you guys to pause me here, try that one on your own, and come back, see how you do. So pause and try that one on your own. Okay, full disclosure, I paused it too early. So I paused and then I unpaused and then I have no idea where I paused. So I'm hoping we did 8. And I'm hoping that we were able to get here and we were able to see -35i plus 35i canceled, and then 49 plus 25 got me 74. And so notice how when we multiplied the same expression but changed the signs, the real part, or the imaginary part was canceled out and we were just left with the real part. So I am going to turn it over to start a problem that I'd started, but then I realized we weren't recording. This is what happens when I pause and unpause. Okay, so I had started 5 plus 2i over 3 minus 4i. Now, it's really similar to rationalizing the denominator. So when we have an I in the denominator, essentially that is a square root in the denominator. And as we know from our prior units, we cannot have a square root in the denominator, so we have to rationalize it. An expression cannot have an I in the denominator because it is a square root. I is the same as the square root of -1. So what I want you guys to do, I multiplied top and bottom, just like we did with the square roots, by the same expression, just changed the sign. So it's 3 minus 4i, so I multiplied top and bottom by 3 plus 4i and 3 plus 4i. So what I want you guys to do is just start by multiplying 5 plus 2i times 3 plus 4i. So just start that on your own, pause me here, and try that on your own. So when I multiplied that together, I got 15 plus 20i plus 6i plus 8i squared. Now remember that 8i squared, we can simplify that further. We know I squared is the same as -1. And so what happens is that's 8 times -1. Okay, now what I want you guys to do is multiply the denominator together. So multiply 3 minus 4i times 3 plus 4i. So try that on your own. Pause me here and try that one on your own. Okay, so when I multiplied, I got 9 plus 12i minus 12i minus 16i squared. Again, we know I squared simplifies to be negative 1. Okay, now what do you notice happens at the bottom? 12i minus 12i, the imaginary part cancels out, which is what we want. We don't want an I in the denominator. So I can start to just simplify and combine like terms. This is going to be 15, and then 8 times 1 is negative 8. So 15 minus 8 is 7. And then 20i plus 6i is 26i. And then divided by, this is negative 16 times negative 1, so it's positive 16. 9 plus 16 is 25. Now, of course, we always check to see if we can simplify. Just like with your square roots before, it has to be all of them or none of them at all. So does 7, 26, and 25 have anything in common? And they don't, so this is my final answer. Okay, so then what I want you guys to do is I want you guys to look at the next problem. I'm going to have you guys try this one on your own. So number 10 is going to be 3 plus 5i divided by 6 minus 4i. So first, just think about what are you going to multiply top and bottom by to get rid of the I in the denominator? Because remember, that's our whole goal, is to get rid of I in the denominator. So pause and think about what you're going to multiply, write it down, and come back and check your work. And if you were thinking 6 plus 4i, because you're changing the sign but keeping everything else the same, you would be correct. So multiply the top and multiply the bottom, and then come back to check your work. Okay, so I multiplied the top and the bottom, so just double check that you guys got the same thing as I did, and then I'm going to start to simplify. Okay, so when I combined like terms and then canceled anything out, I got negative 2 plus 42i divided by 52. Now, I want to see if I can reduce that. Again, I'm thinking, does negative 2, 42, and 52 all have a number that goes evenly into it? And the answer with this one is yes. 2 goes evenly into all 3 of those. So remember, just like radicals, it's all or nothing. So negative 2 divided by 2 is negative 1. 42 divided by 2 is 21. The I stays the same. And 52 divided by 2 is 26. So notice we canceled all of them, not just a few of them. So my final answer here would be negative 1 plus 21i all over 26. And that's it. Okay, so our last section, and we're only going to do one more example. Our last section is, when are we applying this? So we are applying this in quadratics. So our last section is just solving quadratics in the complex number system. Okay. So if I gave you a quadratic, so if I give you a quadratic like 2x squared minus 6x plus 5 equals 0, and I said solve that. First, of course, I'd see, can I factor it? Do I know two numbers that multiply together to get me 10 and add to get me negative 6? I don't. So from there, I would just go straight to the quadratic formula. So x equals the opposite of b. So opposite of negative 6 is positive 6, plus or minus b squared, so negative 6 squared, minus 4 times a, which is 2, times c, which is 5, divided by 2a. And then we simplify. So I simplify the inside first. That's negative 6 squared is 36. I would actually just do this whole thing in my calculator. And so I'd just do 6 squared. I know it's negative 6 squared, but I know that negative and negative is going to become a positive. If you did do that, you'd have to put it in parentheses. So you'd have to do negative 6 squared minus 4 times 2 times 5. And that gets me negative 4. all over 2 times 2, which is 4. Now, -4. Before, at this point, we'd say there's no real solution. But now we know we can simplify it further. Well, we know what the square root of 4 is. It's 2. And we know what the square root of -1 is. It's I. So I can rewrite this as 6 plus or minus 2i over 4. Now, I think, can I simplify that further? Do I know a number that goes evenly into both 6, 2, and 4? Remember, all or nothing. And I do. 2 goes evenly into all 3 of those numbers. 6 divided by 2 is 3, 2 divided by 2 is 1, and 4 divided by 2 is 2. So my final answer is x equals 3 plus or minus 1i, which we can just write as I, divided by 2. And that is your complex solution. And that is it. So that is the notes. We will review this next time we are in class. If you guys have any questions, please bring them to class, and I will see you guys soon. Have a great day.